Hello, thanks for coming to today's webinar about leveraging Rhino commands when working with T-Splines. My name is Matt Cederberg and I'm one of the co-founders of T-Splines Inc. and I'm joined today by Kyle Houchins, the owner of the Outside Digital Art and Design and one of our T-Splines trainers, and some other T-Splines staff that's here as well to answer your questions during the webinar. So I'll just start out by briefly introducing T-Splines for Rhino, and then we'll turn the time over to Kyle to go ahead and show how to use Rhino commands to really leverage your T-Splines modeling. So T-Splines for Rhino is it's a fully integrated plugin inside Rhino that lets you more easily and quickly create freeform organic designs. Using T-Splines, you can design while you model, so you can create your T-Splines design, and then rather than needing to, when you make iterations, go all the way back to the curves, you can actually just push and pull on the model to get at the design that you're looking for. That lets you make your revisions in minutes instead of hours, because the T-Spline model is curvature continuous by default, so everything stays together nicely. Can help you win more business by getting those iterations done faster, make your work more intuitive and fun. And finally, one of the main advantages of T-Splines for Rhino is that it is fully integrated inside of Rhino rather than being a standalone application dedicated solely to creating organic shapes. T-Splines lets you leverage a lot of the familiar Rhino commands to edit your T-Splines model. So that's something that we've often talked about, and let me just pull up our T-Splines user manual. Hopefully some of you have seen this in the user manual. You can look at one of our appendices which lists how Rhino commands interact with T-Splines. So as you here we kind of have a list of really just a lot of commands that you can use to leverage your T-Splines modeling. But we've never really taken time to call out some of the most useful commands and focus on them and really show how they make T-Splines much more than an organic modeler, but give you access to commands for advanced shape creation, manipulation, and analysis. So that's what we'll talk about throughout the webinar today. As I turn the time over to Kyle Houchins, as he'll walk through a bunch of Rhino commands and show how they can be used to increase the things that you can do with T-Splines for Rhino. So let me go ahead and turn the time over to him. And before I do that, I'll just give some items of information about how this webinar works. If you haven't done one of these webinars with us before, all the attendees are muted so that the sound stays clear, but we really value your participation. So if you'll just type in questions to us in that questions box of the GoToWebinar panel, then we will be typing answers back to you throughout the webinar. And then also some of the questions we will just ask Kyle live at the end of the webinar, so that we can really have this be a participative event. We ask on our Facebook page just before the webinar started for you to list some of your favorite Rhino commands to work with T-Splines, and we got some great suggestions. And if we don't share some of the ones that work best for you during the webinar today, please go ahead and type them in, and we can share those with the rest of the group as well. So now we'll turn the time over to Kyle. Kyle, again, is the owner of the Outside Digital Art and Design. He's he consults with us, but he also uses T-Splines every day in his business. And he has modeled over 1,000 vehicles for the toy and entertainment industries. So I'll go ahead and turn the time over to Kyle.
Hello, everybody. Thanks for coming. As Matt said, this webinar is going to be a little different than some of the other ones that we've done in the past. We're going to focus mostly on the kind of the relationship between how T-Splines and Rhino play nicely together. Everyone already knows that basically T-Splines is fully integrated within the Rhino environment and allows you to seamlessly transition back and forth between the two products. But we've never really highlighted exactly how well that relationship is established. And so Juan took the time to put a toolbar, which will be posted as part of this webinar. You can take this and use it in your own work. And we wanted to show, basically, these are all Rhino commands outside of the T-Splines toolbar, and we wanted to show how they affect T-Spline surfaces to allow you to kind of use the best tools out of both worlds to get the best model you can. So I'm going to assume, for the most part, that everyone here is fairly familiar with T-Splines and the interface and all that kind of stuff, so I'm not going to spend a whole lot of time on that. If you have questions, go ahead and type them in. Juan and Joe and Matt are going to be answering questions as I go, and if anything needs to get explained live, they'll jump in and we'll go ahead and cover that. So feel free, if you're seeing something that you're getting lost, go ahead and ask. We definitely like to do these kind of on an interactive basis and make sure that everybody leaves with a little piece of information that's going to make their job a little better going forward. So. So what I'm going to do is basically just start off. In Juan's toolbar, he basically put together kind of a sampling of the commands that can be used on T-Splines objects within Rhino. And so what I'm going to do, I have my demo set up in layers over here, and I'm going to go through that, but I'm also going to go through the toolbars. So between the two, you should be able to duplicate this in your own work. The first one we want to cover is just a simple curve, and in this case we're going to use a control point curve, but an edit point curve will work as well. And I have set up here just a simple Rhino curve. There's nothing special about it. It's the same curve that you've drawn a million times in every other type of work. And what we'll do is just pick this curve and then extrude it into a T-spline surface using the drag manipulator and alt-clicking on one of the handles, and you see that we can extrude a surface with it. So you can start either the append face workflow that you've seen me do a million times, or you can actually start with a curve and start generating surfaces off of that, and then obviously once you have an edge, you're just alt-dragging to make shapes off of that. So you can start with a simple curve if you need to start with an exact shape. You can also start with the edge of a NURBS surface. You just duplicate the edge and alt drag from there. So that's how you would start with a curve. The next one we want to look at is sweep 2, and basically sweep 1 or sweep 2 does work. In this case, I'm going to go ahead and show sweep 2, and what we're going to do is just quickly, why is this locked? Sweep 2. Fantastic. What do we got going on here? All right. This is misbehaving. Hang on just a second.
I wonder if it looks like you have record history on Kyle, and maybe you have locked children on. You might need to right-click on record history to unlock the children if they are locked. There you go.
There we go. There we go. Alrighty, so we're going to pick two rails and just make a sweep 2 surface. I can use any of the functions in here. I can refit it. And then I have a simple NURBS surface. If I bring up my heads-up display and pick it, you'll notice that it's listed as a NURBS surface. And then it's a simple matter of just changing to a single button click to change into a T-Splines object. You'll notice now that it's changed into a T-Spline surface, retaining all the curvature and everything of my original surface, but I have the editability of being able to come in here and grab faces and move it. So you can start with a NURBS surface, you can start with a curve, simple conversion or an alt drag, and you're back into the T-Splines environment.
Kyle, just one question. What's the display mode that you have? Is it the TS Shiny mode that you have on there?
I am using shaded in this one. I don't have TS Shiny loaded in this one. I have it loaded in my V5 version. But,
okay, great.
It's essentially, the basis for what we use to make TS Shiny.
Okay. Hey, no, this looks great.
All right. So get rid of this. The next one I want to look at is Revolve, And Revolve is cool because within Rhino it's historically linked. So if I revolve this and create a revolved shape, I can turn on my control points within Rhino. And actually, I think I have. Can move this, and my shape will update. It always surprises me every time I show this. There's people out there who don't know that this tool is historically linked within Rhino. So you could do some basic adjustments here with your curve, and then again, you're just looking at a single button click to go from a Rhino surface to a T-Splines object. It says that broke the history, which is fine. You do lose the history between the curve and the T-Splines object, but at this point it's a fully editable T-Splines surface. We can come in here and then make any further edits, or we can extrude faces, anything like that that you would normally be able to do off of a T-Splines surface. So you can start with a curve and revolve. The next thing I want to look at is a network surface, and basically a network surface is a collection of curves arranged in kind of a quad layout. In this particular case, I'm positional continuity here and here, here and here, but if you get into the center here, you'll notice that these are not actually touching, they're just kind of close enough for government work. I'm going to drag all of these and then use the Network Surfaces tool. And I'm going to drop the tolerance on this because I just want an approximation. You can tighten this down to the point where it's, absolutely positively right on, but for this case, I'm just going to use a little bit looser interpretation. I can preview it to see what it looks like and then accept it. And so right now I have a NURBS surface. If I pick that, you'll see up here in the heads-up display that it's being recognized as a NURBS surface. Again, single button click under the creation menu, convert to NURBS. I'm going to lose my history to my original curves, which is okay. And then I'm right back into T-Splines where I can start modifying as needed.
Hey, Kyle, here's a question. This came in about when you're using the T-Splines manipulator. What are those? Can you show off what those discs will do when you drag the discs?
Absolutely. This is basically the T-Splines manipulator is a simple triad, just like you've seen in a lot of other CAD programs. There's move, there's rotate, there's scale, and then the T key. If I hit the T key, I can move the manipulator, which not a lot of people know right off the bat. But what the T-Splines guys have additionally added these construction plane discs, and basically each disc corresponds with a pair of manipulator handles. So this disc corresponds with the XY, this disc corresponds with the XZ, and this disc corresponds with the YZ. And so if I want to move in 2 dimensions, I can pick that, and I'm moving. If I rotate this a little bit, you can see it better. I'm only moving in 2 dimensions. So it's a really simple way when you're working in 3D to know that you're only moving or scaling or rotating in those particular 2 dimensions. What happens if I grab the center of this and I start moving it? It's a little harder to control because I don't exactly know where the unconstrained manipulation is going to go, and sometimes I can create the situation that I don't really want. Whereas if I know I'm just moving up and down here, I'm just moving in and out here, and I'm just moving forward and back here, it allows me to kind of keep myself oriented within space using those. So get my 1-dimensional manipulation here, my 2-dimensional manipulation here, and then an unconstrained 3-dimensional manipulation if I go for the center. And that translates throughout the other manipulators. If I want to scale in 2D, I go here. If I want to scale in 1D, I go here. And if I want unconstrained scale in 3 dimensions, I go here. Okay? So the other thing that we can do with a T-spline surface, and we know this is a T-spline surface because when I pick it using the object manipulator, it tells me that I have a T-spline surface here. If you're not referencing this heads-up display to kind of keep an eye on what data you're picking, I encourage you to do so, especially if you're in a situation where you're getting in to start welding verts and stuff like that. You'll notice that when I just picked this, I got 3 verts and a curve. So I know I don't want to modify the curve, so I can deselect it. And then I've got another curve over here, and I can deselect that. So now I know for absolute positive sure I've only got 3 T-splines vertices. That's all I'm going to be modifying. I'm going to be leaving the rest of the stuff alone. So reference this as you're going, and it can help you in situations where sometimes you've got an error. If you've welded 2 surfaces together and you highlight a vert, you want to make sure that this is 1. If you've got 2, 3, 4, 5, 6, 7 verts when there should only be 1, then that means that you've got a stacked vert situation. You need to weld to get rid of those. So use the heads-up display. It's really helpful. The next thing we're going to do is project a curve onto a T-spline surface. And if I go to the top view, I can pick this curve, and I can just project it onto this. And you'll notice that that curve goes onto that surface. I can then pick this curve, and I can alt drag off of that to create another T-spline surface. So it allows you to be able to project curves onto a surface in order to be able to get an exact border or something like that that you wanted to do. So remember, you can't trim stuff yet. Something that we're working on, but you can project stuff onto a curve or onto a surface if you need to get an exact surface from there. If you do trim it, it's going to turn into a NURBS object.
Yeah, just to clarify that. Good point.
Okay. Next thing we want to look at is volume. And in this case, for this little golf club that I put together, I want to be able to determine what the weight of this thing is so I can adjust the swing weight or the performance of the club. And so it's going to be important for me to know what the volume is. And under the Analyze Mass Properties, I've got volume, or you can use Juan's toolbar here. And you'll notice up here it says it's 2.23 blah, 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 plus or minus cubic inches. Well, the cool thing about this is I can go back and do the math on the cubic inches versus the weight of the material and determine exactly what the part weight on this thing is going to be. Say I'm a little bit light and I need to add a little bit of beef to this thing so that it has the appropriate swing weight. Well, all I need to do is come back here and move the T-splines vert, add a little thickness here, rerun volume, and you'll notice that I'm now at 2.4638. So I can basically go in and just dial in exactly to my volume what I need as far as being able to adjust part weight. One thing that I'm pushing for, and I'll give you Matt's home phone number so you can call him in the middle of the night and help me get this, is to be able to have this be live so that as I'm picking these buttons and moving them, the volume updates automatically. So they've heard me whine about it for a while, so go ahead and whine about it yourself, and hopefully we can get that added in there.
Yeah, I just want to chip in. I just think this is some of these analysis tools I think are some of the most powerful things of how you can integrate Rhino with T-splines. So using things like this volume calculation, then just tweaking the control point to change that, I think is really powerful. And as far as getting that to just to update in real time, that is something we're looking at getting in. But if you are a Grasshopper user, it's very straightforward to kind of hook up a little Grasshopper setup so that you can see that updating with Grasshopper in the meantime. But
I'll still give you Matt's home phone number so you can call him about him. I'm kidding. Don't bug Matt. We love Matt. All right. The next one is the volume centroid. If I pick this, it's going to tell me where the center of this volume is, which is right there. And it works better if I do it in wireframe mode. So let me do that again so you can see what happens. If I want to know exactly where the center of this volume is, I can pick this, and it's going to drop a point right smack dab in the volumetric center of this part. The next thing that we want to look at is zebra, and this is fantastic for analyzing curvature. And one of the things that T-Splines does really, really good is curvature continuity. So this is a fantastic tool to be able to demonstrate that. And you'll notice that we have really sweet curvature continuous lines all over the place. And one thing that's really awesome about this is if I show the ISO curves here and I go into edge mode, I can pick an edge. Oops, edge mode. I can pick an edge, and I can interactively update this, and you notice that the curvature will recalculate. So if you're getting an area where you've got some bunching, or the highlights are doing funky things, throw a zebra on it, and you can come in here even on the vert level, and using my construction plane disk, I can move this vert just a little bit, and then I'm going to watch my lines update, and I can get a pretty good feel for how those highlights are going to track, which is, if you're a highlight nerd like me, is really big fun. You can just come in here and watch that stuff update and know what you're looking for. Okay, remove the object, just right-click on it, close out of the zebra command, and go from there. Now, one thing that we didn't cover, and I do believe it works, is the EMAP, where if I bring this up, I can throw an EMAP on it, which allows me a really, really shiny preview for marketing people because they love shiny things. You can throw it on here and evaluate the highlights. I can change the map that's on that in here and see exactly what that looks like. Again, just remove the object to get out of that. So EMAP and Zebra are both great things if you're a highlight nerd like me for evaluating that kind of stuff. The other thing that we can do is a curvature analysis. And basically we're going to just get a pictorial and numerical kind of explanation as to what the curvature is going on. So we know we've got a little bit of bend here because this is not all red. We know we've got some tighter curvature here in the edges, stuff like that. So it helps you if you've got a situation like this where you've got a big flat surface and then you've got a green dot in the middle of it, you know that there's an inflection here. In this case, this is happening gradually and within kind of the confines of what I want it to do. But for instance, if I had a point here and it had a dent in it, it's going to show up. So obviously I don't want this thing to have a dent in it. This curvature display shows you pretty graphically what's going on, and so then I can go in and I can just pull this stuff out. And as Matt was saying, these kind of controls, this is the kind of stuff that like T-Splines is just miraculous for, because doing this in NURBS would require a lot of iteration, and if you were grabbing control points on a surface and starting to move these things around, obviously on a NURBS model the thing's going to start tearing apart on you. With T-Splines, since this stuff is basically a single surface model, you can edit these points and not tear the model apart and know that you've got good surfaces. So if you've got an issue, you've got a dent, you're working on a car and there's a ripple in the side of the car, you're going to be able to see it. Go in, grab the edit points, and just do a little body work on it and remove it. So awesome, super powerful capabilities within T-Splines. And then one of my favorites is the draft, and I'm going to use this golf club again. If I throw a draft analysis on this, and this works off the construction plane, by the way, so if the construction plane is in this XY configuration, it's assuming that the draft is going to pull top to bottom. So in this case, I'm going to set the construction plane to world front. Set construction plane, world front. So this is going to assume that the pull is going to go front to back, which is basically how you mold this thing. So I throw a draft analysis on this, and you'll notice that I look really good all the way around this part. Everything is doing what it needs to be. I may need to adjust this just a hair. So if I want to pull the parting line back just a little bit, I just drop this guy. Actually, I need to raise it. And you'll notice I can actually move the parting line a little bit to make sure that it's doing what I want. So that's a little better representation of the parting line. And then back here, you'll notice that it's indicating that there's an undercut here. And so what I'm going to do is I'm going to adjust this profile ever so slightly until that undercut disappears. And if you're looking for the one reason you came to this webinar, this is it right here, because being able to do this interactively and watch your undercuts disappear is nothing short of absolutely positively amazing. So I can just dial this in. My undercut's going to disappear. I notice I've still got another little undercut here, so I'm going to grab this edge and I'm going to just squeeze that out just a hair. I'm going to pull this one in just a hair. Undercut's gone. You love this. One of the coolest things about being able to use T-Splines with draft. All right, close this out. That goes away. Let's look at using some of the UDT tools. Again, some of my favorites. And well, let's see. The next one in here that we'll look at is the check edges. So I can pick this. I can hit check edges, and obviously I've got two open edges here, so they're going to light up. I can show all edges or naked edges, and so that just is showing me that there's an open surface here. If I go back to my golf club and I add this object, you'll notice up here it says there's 40 edges total, but none of them are naked. So that's indicating that the fidelity of this surface is closed manifold. This will export to STL. This will export to CNC. This will export to Pro-E SolidWorks using the new TS Elements SolidWorks plugin. And this is really good, solid, data. All right, so let's go back to bend. And the thing to keep in mind about the UDTs is they will work on either the points or the object. Let's see, that's a surface. Oh, well, let's turn it into a T-Splines object. All right, so now we're a T-Splines object. The UDTs will work on the object. If I pick this object and I go to my top view and I bend this thing, they'll work just fine. But you'll notice that it converted it back to a NURBS object. That's not what I want. If I do it on the verts, if I turn the verts on, pick the verts, and bend the T-spline verts, you'll notice that it keeps it a T-splines object. It's a pretty wicked bend, but if I go to my object here and pick it, you'll notice that it stayed a T-spline surface. So if you're going to use UDTs, make sure that you're using them on the verts and not the object. With this tortured object, let me bend this again so I can get it just a little less tortured, just because I can't stand looking at it. I'm going to take this, I'm going to bend it right through the middle, bend it up a little bit like that. And so I've got my nice bend in the front here that I wanted, and then say I want to flatten these points out. So what I'm going to do is I'm going to pick these verts and then pick these verts. And I want to flatten those out. If I go from my top view, I want these to be straight across, but I want to maintain my bend in the front. So I'm going to use the set points command. And I built a little button here. So if you hit that, it's going to bring up your XYZ coordinates, and in this case I want to set them to the Y, and so I'm going to shut off everything except for the Y and say go, and you'll notice that those points line up like little airplanes coming into JFK, and then you can just pick the spot where you want them to go. Once they're lined up, you can move them, or for that case, if you want to get really slick, you can bend them again and start getting some really interesting shapes using the UDTs. I use this all the time. Set point, bend, and stuff like that. The UDTs within T-Splines are really, really phenomenal. So I would encourage you, if you haven't explored that, to enjoy that. The next thing that we're going to look at is flow. And again, this is a UDT command. And it's super, super powerful, and I'll show it in the front view so that it's really obvious what's going on here. Again, it will work if I pick this object and flow it. It'll flow, but the result is going to be a T-Splines, is going to be a NURBS object. So that's not what I want. I want to be able to maintain the editability of this. So you notice here that I have a T-Spline surface. I'm going to go to vert mode and make sure that I'm picking verts. Then I'm going to flow, pick my starting spline, pick my ending spline, and it flows along the curve, but if I go back to my object and look at it, it's a T-spline surface. This is fairly dense. It's probably way denser than it needs to be, but I wanted to just illustrate the fact that, you know, it doesn't have to be a simple shape. The UDTs are super, super powerful, and they can handle pretty much anything that you can throw at them as long as you're doing the operation on the right type of geometry. So points, not surfaces or objects, and you can use the UDTs all day long.
Yeah, just one note about using those UDTs with T-Splines. One of the benefits of T-Splines is that it lets you do really organic things and push and pull each control point interface individually, but the UDTs let you move everything kind of in a more uniform way to add a little bit of control to that T-Splines manipulation. So using the T-Splines faces, edges, and vertices to just do your tweaks and kind of sculpting it like digital clay works really well, but then being able to combine that with these Rhino UDT tools to get some more predictable movements, I think it's a really powerful combination.
Yeah, absolutely. And to Matt's point, you know, I do this all the time where I'll make an object and then I'll get it just about right, but it needs to be a little thicker or a little thinner or a little taller or a little, you know, it just needs like a little tweak so that it looks like art and not computer art. And you know, I'll get into the UDTs and say, for instance, you've modeled something symmetrically, and you just need to give, you know, you've done a character or something, you just need to give them a little bit of bend to his spine or a little bit of something just so it's not static and sitting there like you know, a bug on an examination table. You know, you can grab the UDT tools and go in and just bend and twist and move them around just a little bit so that it gets that touch that like I said, again, makes it look like art and not computer art. So so let's look at the last one that I want to show today, which is taper. And again, this is another UDT tool, and so knowing that, we want to make sure that we're working on the verts. And so I'm just going to pick this object. I'm going to go with the taper. I'm going to pick my center line here, and the bottom, you'll notice the way the interface works, it's going to say, okay, where are you going to start from? So I'm going to say here, that's going to be my fat part, and then this is going to be my skinny part, and then it's going to taper. So you'll notice that it got a really great symmetrical, overall, very controllable, very predictable taper by using that tool. So that's you know, a really great way to add a little bit of character, add some modification to your part, and in a very predictable way without having to go in and actually move the individual bits. So that's pretty much what I have to show for you today. If you have any questions, please jump on, and we'll be happy to cover you know, cover anything live here that you're questioning or anything like that. So.
Let's see, Kyle, we've got some questions coming in. Before we
Yeah.
get to those, let me just switch over and make myself the presenter again and just introduce a couple of the upcoming webinars that we have going on in the next little bit. So again, thanks everyone for coming today to this webinar for T-Splines for Rhino, just showing how you can use those Rhino commands to really leverage the T-Splines organic modeling tool. So I hope that those, especially those surface creation, surface analysis, and the UDT tools can really take your T-Splines modeling to the next level. But next week we have our very first webinar introducing a new product that we're very excited about. It's called TS Elements for SolidWorks. And this is our first product that's integrated inside of SolidWorks. It lets you take a model that you've created inside T-Splines for Rhino, push that into SolidWorks, and then have it be fully integrated into the feature tree and still be able to edit the points, edges, and faces of that T-Splines model. So that webinar will be next Tuesday. We'll be showing off how that works. And then a week from Tuesday, we're going to have an instructional webinar. This is a follow-up to a webinar that we had just before the holidays with Klaus Kuhnen. The previous webinar, he showed how to model the Swede nunchuck with T-Splines, and now he's going to show how to render that using V-Ray. So this is a unique webinar for us in that T-Splines will not, we're not showing T-Splines per se in this webinar, but another product that we resell, V-Ray for Rhino, and how those two products work together really for the modeling and the rendering. So there'll be links for you to sign up for these webinars in the follow-up email that you'll receive. So with that, let's go ahead and turn the time back over to Kyle, and we can go ahead and answer some of these questions.
Great.
Let's see.
There's one in here. It says, is there anything like fit surf inside of T-Splines? I often convert NURBS to TS object and end up with too many faces. TS fit surf would really help to reduce face count. Basically, the way to do that is if I go back to my network surface here, this gets a big fat surface with lots of points in it. If let me show this. If I rebuild this surface using the Rhino rebuild command, it comes up and it tells me basically, you know, I'm 9 in the U, 13 in the V. I can drop that to, you know, if I want, 4 and 4, and then preview it, and I can calculate the maximum deviation. In this case, it's, you know, 0.4 units, which might be too much. So let's raise this a little bit to 6 and 6. Preview that again and calculate. We're still 3.8. Maybe we go 8 and 8. And 0.16. I'm going to call that good enough for this particular thing, and then say OK. It's going to rebuild. I'm going to have, you know, less control points that then once I switch to, you know, convert to a T-Splines object. I'm going to have less control points. You know, I can rebuild this further if I go back to the surfaces, go back to my original surface. I can rebuild this again. You know, I can drop this to whatever I want and say OK. And obviously, you know, you can really drop the point count on that using the Rhino rebuild command.
Let's see, a couple more questions, Kyle. Does the object info data at the top right of the screen come on automatically? I think that's referring to the heads-up display. If you could just show how you can toggle that on and off.
I'm sorry, Matt. Say that one more time.
Yeah, the heads-up display in the top right of your screen. Can you just show how you can turn that on and off?
Yes. I use the control spacebar, which is the hotkey for turning that on and off. Or you can just use the button here in the T-Splines toolbar. You can right-click to bring it up, or left I'm sorry, right click to hide it, and I always get this backwards.
Oh yeah,
left click to show it, right click to hide it.
Yeah, and right click actually just hides the actual manipulator. It won't.
Okay.
You'll just hit the escape key to get rid of the heads-up display.
Got it. So either hit the button to bring it up, escape to make it go away, or control space to bring it up, control space to hide it.
Okay, so here's another another question. How do you get the 9 points that define the face of the golf cutter to be coplanar?
I would use the set point command, and basically if I go back to this, let's use this one. So if I turn on my verts and I pick these points, I can, basically, well, I'll just run around here and define this. So I've got all those points, and I want to make sure that those are absolutely dead flat. I would use the set point command, and I would flatten them out, and then once I had them flattened out, I would manipulate them and get them back to where they needed to be using either the manipulator or the rotate tool. So now I can go back and rotate those. So I know it's dead flat now, and I can put that back where it needs to be.
Yeah, one other way, and you can tell me if you ever use this, Kyle, is we actually have a flatten control points command inside of T-Splines that will just flatten the control points. It doesn't flatten them to one of the global planes, but it flattens them to the plane that just kind of fits those points best. So you might want to grab that in just maybe the T-Splines drop-down menu.
Yeah.
If you go to, let's see, where would it be? Maybe utilities at the very bottom. Check out utilities, flatten points. That I don't know, Kyle. Would that suit this purpose as well?
Matt, I tend to use the set point just because it's so predictable, but flatten actually does work pretty well. You'll notice that if I take one point and I yank it kind of out of sync here, where the other ones are straightened out, if I go to the utilities and then flatten points, it's going to find kind of a common plane for those all to fit on, and you'll notice that it did it, but and that's useful in a lot of circumstances. But for a circumstance like this where you'd want the whole thing to be dead flat, I would probably set points and then move it back.
That's true. There's no guarantee that it might be rotated slightly on one axis or something. So.
Yeah, because it approximates, basically approximates all the points that are there and then throws kind of an arbitrary plane through it. Where, being a control freak designer, I like to be able to make sure that everything's exactly where I want it to be.
Yep. Okay. Let's see. So here's a comment. When Kyle projected a curve on a surface, he was able to extrude the curve, whereas I'm only able to move it upwards. And I didn't quite catch how you extruded that. Did you use the T-Splines extrude curve, Kyle?
For the curve?
Yeah, when you projected it.
No, that was just a simple. Just a Rhino project curve. So.
Oh, but then did you extrude that after you projected it?
Yeah. I picked that curve and then just alt dragged on the manipulator to extrude the surface.
Okay. Yeah, and that's the trick. If you hold down the alt key when you use the manipulator, then it will make an extrusion. And if you just move the manipulator, then it won't. So
if I have a surface here, in this case I'll just make a quick 4-point surface, convert it to T-Splines. So now it's a T-Splines object, T-Spline surface, and I take this curve and I use the Rhino project curve tool. I've projected a curve onto that surface. Now I can pick that curve and then Alt drag to create T-Splines geometry off of that.
So here's another command. How would you know what the angle of the club face is, like if it was a 3-iron or a 5-iron?
I would probably, I'm not a golf club designer and I'm not even a very good golfer, so don't hang me out to dry here, but the way that I would handle that is I would probably set up a I'd set up a plane, you know, probably start here and then rotate it, you know, say -5 degrees. So now I know this is 5 degrees off of you know, normal. And then what I can do is I can grab all these points, and in this case what I'll do is, let's just say I'm going to grab all of these, and then I'll use the set points command and make it flat. Oops, looks like I missed one. Missed the center one. All right, so I'll set points, make it flat, and then what I'll do is go to my rotate manipulator, and if I double click on this, I can enter the rotation degrees. So in this case, I just enter -5, and now I know, and I can verify that by moving this over. I'm -5 degrees. So I can specify by double-clicking on the manipulator, and that works in all the manipulators. If I want to move at a specific number of units, I can double-click on a manipulator handle, and then I can, you know, say move it 1, or I can double-click on it and say move it -2, and I can move it to a certain specification. Same thing with the rotate manipulator. If I bring this up, if I double-click on the handle that I want to modify, I can make that rotate in 10 degrees. Double-click on it again, I can rotate it -10 degrees. So there is some mathematical control within the manipulators. So if you needed to make sure that this face angle was absolutely positively, you know, dead on, you could do that. And once you have it adjusted, as long as you're moving, you know, only in one direction, you're, you know, pretty much guaranteed that this is going to be, you know, 5 degrees or whatever you wanted to do it at. So, and I may have, looks like I missed a point down there, which made that little scoop, but I think you get the idea.
So here's a question about someone using T-Splines with another plugin like Rhino Gold. So he's converting the T-Splines to NURBS and then wants to set the stones, but he's getting multiple NURBS surfaces from the T-Spline. Do you want to just show kind of how the T-Spline, or maybe I'll kind of talk this through and you can show it, but one of the main differences between T-Splines and NURBS is that the T-Spline can actually have a non-rectangular surface. There's no possible way to make this form with a single NURBS surface. So when you convert the T-Spline back to NURBS, it has to split it up into some patches. And the way that it does that by default is every point that there's a start point will be the corner of the new NURBS surfaces. So do you just want to go ahead and just convert this to a Rhino object, Kyle, just to show how it does that by default?
Okay, it's really hard. Everyone pay attention. I'm going to right-click and left-click, and then right-click to accept. Poof, NURBS.
Yeah, so the way that there's a few different controls about how you can specify this to be split up, but if you are using something like Rhino Gold that's setting gems on specific surfaces, you will want to be aware of the NURBS patch layout inside T-Splines. So if you want to undo and go back to T-Splines, Kyle, and then just go ahead and go in the T-Splines drop-down menu and click on, let's see, I think it's probably Utilities. Yeah, Define Regions for Conversion. This will show you how the T-Spline is going to be broken up. And Rhino unfortunately doesn't give us a lot of leeway as far as where some of the boundaries are, but you do have the option of clicking on different parts of the surface to show where the different boundaries are. So if you have more questions about that, go ahead and post it on our forum. So here's another question. If you took a 5-degree, okay, let me read this again. If you took that 5-degree curve and made a surface, could you project selected verts to that surface? I don't know. Can you project T-Splines vertices onto surfaces, Kyle? I guess I've never tried that before.
You know, I honestly haven't either. I always just set points, and then if I need a specific angle, I set them flat first so I know that they're all zeroed out, and then I move them again. Yeah, I've never tried that.
Okay. Well, we can. Yeah, Jody, if you want to go ahead and check that out, we'd love to hear about that. But
yeah, I think set points only works to world construction planes. I don't know if you can project them to a construction plane or not.
Yeah.
I think it's just. Let's see. I think that dialog box just, if I go back, if I pick one of these and then set points. It looks like it can align to a construction plane. So if that's the case, you theoretically would be able to define a custom construction plane, and then that would be 5 degrees off, and then align it to that. So yeah, I think that would work. I don't want to try and demo it live because we're on as I try and figure it out in front of everybody. But let's just say that's a theoretical yes.
Okay. Well, good. Well, I hope that. Today's a helpful webinar for everyone. One thing that we really, that's really important to us with the T-Splines community is that kind of as a community, everyone kind of learns together and learns better ways of taking advantage of the T-Splines tools, and certainly using the powerful Rhino tools gives you a lot of power there as far as your organic modeling goes. So thanks again for
Matt,
yeah.
I just want to jump in really quick here. The one I just thought of a potential complication when using the draft analysis and stuff like that. Make sure in the newer versions of T-Splines, in the WIPs and in the upcoming version 3 release, there's a new display option here, and there's 3 settings in here: compatible, fast, and fastest. There's a dramatic speed increase for going with fast and fastest, but you will see a display discontinuity on the screen. And if you're using the Zebra or the Draft or anything like that in fastest mode, you're not going to get accurate results. It's the Zebra in particular is going to show discontinuities in the surface, especially in fast and fastest. That's just a display thing. So if you're using the Draft analysis or the Zebra, make sure that you have your display set to compatible, and then you're going to get the curvature continuous display. And maybe Matt, you can just briefly talk to the 3 differences between what those are.
Oh yeah, with compatible fast and fastest, it's just ways of interacting with your model faster, and yeah, I think Kyle explained it pretty well. So yeah, if you're wanting to use the Rhino commands, the Rhino tools, then it is important to use the compatible. The compatible means that it's compatible with these Rhino tools. So okay, well great. Thanks again for coming, and again, hopefully we'll see you again at our upcoming webinars of TS Elements for SolidWorks and the rendering with V-Ray. And you can look in the next couple business days for an email from us with a link to a recording of this webinar, and also the QA, and then the special Rhino tools toolbar that we put together with these Rhino tools. So thanks again.
Thanks, everybody.